These are the notes for elements in the periodic table. Here are the words to know for this set of notes: atomic number, atomic mass, ion, isotopes, group or family, period, alkali metals, alkali earth metals, halogens, noble gases. These are the key questions. What is an atomic number? What is the atomic mass? What is an ion? Where are the alkali metals, alkali earth metals, halogens, and noble gases? What are the properties of metals, nonmetals, and metalloids? To begin with, let's look at the periodic table. You can see on the periodic table, just based on the colors used in this example, that there are all different types of elements arranged in certain categories. On this side over here, we have all the metals. Over here we have nonmetals, and here we have metalloids, and we have the lanthanide and actinide series on the bottom. All these different parts have their own properties, which makes them unique. Every element is different than the other elements, but in some ways similar based on where it is in the periodic table. First, we need to know what it is we're looking at when we look at the periodic table. In each one of the sections, you will see a square or a rectangle that contains some information. First, we have the atomic number. This tells us how many protons are in the nucleus of that type of atom. For instance, this is helium and it has 2 protons. The atomic number is the whole number in each square of the periodic table usually. Most periodic tables will also have a key to tell you what everything is. We also have the element symbol, as well as the element name, and the atomic mass. The atomic mass is an average mass of all the isotopes of an element. An element can have a different number of neutrons. The element therefore has different isotopes. So for instance, hydrogen can have no neutrons. It can have 1 neutron, or it can have 2 neutrons. In this case, each one of these has a different mass. As we have more neutrons, we have more mass. But most hydrogen exists, as we know it, in the form of hydrogen with no neutrons. So when we look back at this periodic table, we can see an atomic mass very close to 1. So it has a very close mass to 1, but there are a few of these with more neutrons, so it has more mass. So the atomic mass is the average of the isotopes if we added all of them up that we know of. And this usually has a decimal, and it's based on abundance. Helium is fairly abundant, and based on its different abundances of its isotopes, it has an atomic mass of 4.0026. It's also important to note that an AMU, or atomic mass unit, equals the number of protons and neutrons if we added them up. What is an ion? An ion has everything to do with gaining and losing electrons. If an atom has the same number of protons and electrons, it has an overall neutral charge of 0. But if an atom loses an electron, it gets a positive charge. And if it gains an electron, it gets a negative charge. For instance, if we have sodium chloride and it's joined as salt, This is an ionic bond, and in this case, the sodium will actually lose an electron and gain a positive charge, whereas chloride ion it'll get an electron and become negatively charged. They therefore become ions. Now let's look at where all the different parts of the periodic table are. Many periodic tables you'll find will be color-coded, so you'll know what everything is, but you should know where everything is without having a color-coded periodic table. We start with group 1 here. Groups or families go up and down. They're the columns. This group is the alkali metals. The alkali earth metals are next. The alkali metals are known for being very reactive metals, and alkaline metals are somewhat less reactive. These here in purple are the transition metals, and we can find a lot of things that we would actually think of as being metal, like nickel and copper and zinc and silver. Over here we can see our metalloids. These have properties of metals and nonmetals. We also have the nonmetals over here. Some specific nonmetals include the halogens in red and the noble gases in group 18, which are completely unreactive and do not react easily with any of the other elements. And all of these things encompass the periodic table, but remember to look for the group numbers along the top and the period numbers along the side. Some properties of metals include that they are shiny solids at room temperature, and this shininess of metals is called luster. They're also malleable. They can be hammered into shapes. They're ductile. They can be drawn out into wires. And metals are also very good heat and electrical conductors. Nonmetals are not. They're brittle. You can't make them into wires. You can't bang them into sheets. They're also not good conductors of heat or electricity. And most of them are also, they can be solids, liquid, or gases at room temperature, whereas most metals will be solid. Metalloids have some properties of both metals and nonmetals. Silicon, for example, is a semiconductor. Boron isn't necessarily a good metal, but it has some properties of metals. Many of these other ones are used, like germanium and tellurium, are used in electronics for their specific properties. Now, this concludes our basic overview of the periodic table.